Have you ever looked at one of our most advanced systems and just wondered, why do they seem to collapse under their own weight? Well, today we're going to dive into a pretty radical idea called the coherence inversion. It's this concept that suggests the very complexity that usually breaks our systems could actually become their greatest source of fuel. So let's start with this central paradox, right? It's a real head-scratcher. Why do our smartest systems, we're talking everything from AI models to huge organizations, why do they seem to break down precisely when they get more complex and supposedly more powerful? Well, according to this research, the answer requires a total shift in how we look at the problem. See, it's not about a lack of capability. It's not that they aren't smart enough or powerful enough. The real reason these systems fail is because they can't stay coherent. And that one word, coherence, that's the key to this whole thing. So that brings us right to our first big idea here, the capability paradox. I mean, we've all seen this play out, right? We just keep adding more capability, more data, better models, fancier architectures, and we think we're making things stronger. But it's kind of like building a skyscraper higher and higher without ever checking the foundation. Eventually, the whole thing just falls apart. It starts to drift, it gets inconsistent, and it just breaks down. This is what the source material here calls the capability myth. This totally false belief that just throwing more power at the problem will eventually fix the instability. So if just piling on more capability isn't the answer, what have we been getting so wrong? Well, that leads us right to section 2. It turns out we've been fighting the wrong enemy all along. Okay, so the old way of thinking, let's call it the complexity paradigm, had a really simple goal: reduce and control. The entire strategy was built on this idea of trying to wrestle complexity to the ground and pin it down. Basically, the core assumption was that complexity itself is the bad guy. It's the enemy. It's something you have to manage, simplify, and just stamp out if you want to keep your system stable. But here's the kicker. This whole approach has a fatal flaw. The second you put the system under any real load, it just starts to fragment and drift. And what's our brilliant response? We clamp down even harder. We apply more and more external control trying to hold all the pieces together, but that just makes the system even more brittle. And this is where we get the big aha moment. So let's jump into section 3 and check out the alternative, the coherence inversion. This one sentence right here, it flips everything on its head. When coherence is low, complexity overwhelms. When coherence is high, complexity becomes fuel. All of a sudden, the problem isn't the amount of complexity anymore. It's the system's underlying state of coherence. So what is coherence anyway? Well, it's way more than just, agreement or things lining up. Think of it like the DNA of a system. It's its deep, fundamental, structural integrity. It's the magic property that allows all that capability and complexity to build on itself and compound, instead of just shattering into a million pieces. Now, this new paradigm isn't just some vague philosophy. Nope, it's actually built on a really simple but incredibly powerful rule. And that's Section 4, a new governing law. And here it is, just 3 symbols. Delta C is greater than or equal to 0. So what does that actually mean? In plain English, it translates to one simple, non-negotiable, unbreakable rule. Coherence must never decrease, period. No matter what the system does, no matter how it changes, its internal integrity cannot be compromised. That's the bedrock. And this next part is absolutely crucial to get. This is not a rule for managing day-to-day behavior. It's not about telling an AI what to do. It's a structural constraint. It's like instead of trying to steer every single drop of water in a river, you just design the riverbed itself. You design the environment so that the system can't help but evolve in a way that preserves its own coherence. And when you actually design with that constraint in mind, well, something pretty amazing starts to happen. Which brings us to section 5. Complexity becomes fuel. Let's go back to that comparison chart from before. Over on the right, we have the coherence paradigm. And notice the goal. It's not to reduce complexity anymore. It's to align with it and metabolize it, to literally take in new challenges and information and convert them into structural strength, kind of like how a living thing turns food into energy. I mean, the difference here is just, it's night and day. The old way sees complexity as the enemy. The new way sees it as fuel. The old system fragments under pressure. The new one actually gets more stable as its capabilities compound. The whole approach shifts from using constant brute force to just elegant structural design from the very start. Okay, so let's tie this all together in our final section. This is really about a massive fundamental shift in thinking, from trying to control everything to creating the right conditions. This really all boils down to one big shift, which happens across three key inversions. First, we stop focusing on control and start prioritizing coherence. Second, we move from reduction to metabolism. And third, we stop trying to dictate every little behavior and instead focus on designing the conditions that allow success to just emerge naturally. So here's the big takeaway, especially if you're building or leading anything complex. The real power, the real leverage, it's not found in that exhausting, endless battle to manage complexity. It's in designing for coherence right from the get-go, creating systems that are built to be resilient and adaptive from their very core. So we're left with this one elegant, powerful principle. The goal isn't to make our systems less complex, but to make them more coherent. It points to a future where our most advanced systems don't just survive complexity, they actually thrive on it. And it leaves us with a huge question. What could we build if our systems were designed from their DNA out to never, ever lose their integrity? Delta C must be greater than or equal to 0, always.